Okay, so AI coding assistants. They're everywhere, right? The promise is huge. We're all going to be faster, more productive, a revolution in how we build software. But what if that promise has a catch? A really, really big one. Because when you look at the actual data, the story gets, well, a whole lot more complicated than you might think.
You know, for decades, this right here has been the golden rule of software development. The big idea was that code quality, clarity, making it readable for people, that's what mattered most. It's a whole philosophy built for a world where humans were the main ones looking at the code.
But that's just not the world we live in anymore, is it? Now, machines are in the mix. AI agents are getting involved in pretty much every single part of development. And that big shift, it forces us to ask a really fundamental question about what our work even is now.
And that question, well, it leads us straight into this fascinating paradox. On one hand, we're told AI makes us faster, but on the other, the evidence is starting to show it might be making our code a whole lot worse.
I mean, the adoption rate has just been staggering. We're talking millions of developers across tens of thousands of organizations all using these tools. And in some cases, AI is writing nearly half of their code. All of this in the name of one thing: writing more, faster.
But then researchers started to actually dig into the impact of these tools, and they found something completely unexpected. That whole promise of pure speed and efficiency, it starts to fall apart pretty quickly.
Get this. One study found that AI adoption led to a 41% increase in defects. Just let that sink in for a second. More bugs with no measurable increase in overall throughput. So you're not actually delivering more value, you're just delivering more problems. And this is the paradox in action. It's wild. Developers using AI felt like they were 20% faster, but when you actually timed them, they took 19% longer to get the job done, compared to the folks without AI. So we feel super productive, but the stopwatch is telling a totally different story. So what on earth is actually going on?
Well, the answer seems to lie in something called the unhealthy code trap. And it turns out the AI isn't the real problem here. The problem is the environment we're putting it into.
Okay, think of it like this. An AI coding assistant, it's like a brilliant new hire, but one with zero experience. It doesn't have that seasoned judgment, right? It just learns from the code it's looking at. So if you drop it into a clean, beautiful, well-organized code base, it does great. But what happens if you drop it into a tangled, messy legacy nightmare? Well, it just learns all those bad habits and starts pumping out even more messy code.
And this isn't just a theory. Large-scale studies show a 60% higher risk of defects when an AI is working on unhealthy, problematic code. The AI isn't just generating code out of thin air. It's amplifying the quality, or the lack of quality, that's already there.
So, this brings us to a super crucial concept, code health. And this isn't some vague, fuzzy idea, it's a real, measurable metric. It looks at things like code complexity and how easy it is to maintain, and it's been proven to directly connect to how many bugs you'll have and how fast your team can actually go.
So this code health scoring system really breaks it down for us. You've got green code. That's a score of 9 or higher, and that's a super low-risk place for an AI to work. But as soon as you slide into that yellow zone, and especially into the red zone, well, that's where you've got serious technical debt, and the risk of your AI creating new bugs just goes through the roof.
So this all leads us to our first major solution. If the environment is the problem, then we have to fix the environment. We need to make our code AI ready.
Look, the answer here is not to just throw out these incredibly powerful tools. The real solution is to do the hard, foundational work of improving our code quality first. That way, the AI can actually be a helpful partner instead of just another machine for generating legacy code.
And what's so fascinating about this is that the payoff isn't linear. It's not a straight line at all. The value you get back actually accelerates. I mean, sure, moving code from bad to average is good, but the really huge jumps in speed and quality, they happen when you take your code from just good all the way to great. And we can actually put numbers to those benefits. Taking your code health from just an industry average to that top-tier elite level gives you about a 36% boost in development speed and a 39% drop in defects. It's a total win-win. Your human developers get faster and more effective, and you've built a safe playground for your AI.
All right, so we've cleaned up our code base, we're feeling good, but that actually only solves half the problem. Now we got to look at the AI itself because it has a pretty major blind spot.
Let's just ask a quick question here. What if your code base is absolutely pristine, a perfect 10 on the code health scale?
Can you just unleash the AI and let it run wild? Well, as it turns out, the answer is no. And here's the second big piece of the puzzle. These large language models, they're trained to write code that works. It passes the tests, it runs, but it often fails at pretty much everything else. The code can be a mess to read, it ignores best practices, it violates your team's style guides. Basically, it creates a long-term maintenance nightmare. So, how do you fix that? Well, there's this brilliant new technique called comparative prefix tuning. Here's the idea. Instead of just feeding the AI examples of good code, you show it pairs. A good way to do something and a bad way to do the exact same thing. By seeing that comparison side by side, you're not just teaching it patterns, you're actually teaching it taste. It starts to develop an intuition for what makes code high quality and maintainable, not just what works.
So, okay, we've just covered two really distinct problems and two really distinct solutions. Let's pull it all together into one single unified strategy.
To really succeed with AI and software development, you've got to fight on two fronts. First, you have to fix the environment. That means focusing on code health. Think of it as setting up a clean, organized workshop. Second, you have to improve the agent itself, the AI. That means using techniques like quality-aware training. And that's like training a skilled, experienced craftsperson to work in that shop.
And this is the most crucial point. You absolutely need both. They go hand in hand. A master craftsperson can't do their best work in a messy, chaotic workshop, right? And a perfect, pristine workshop is totally useless if you don't have a skilled person to work there. It's the same thing here. You need the healthy code base and the well-trained AI.
So when you think about it, the real question isn't just, should we use AI? It's more like, are we willing to put in the foundational work to actually make it successful? Because the future of software development, it's not going to belong to the teams that just adopt AI the fastest. It's going to belong to the ones who adopt it the smartest.